Number two is about the exam that you did during the weekend. Yeah, well. Iberia is going to cancel some of the exams that he put there from future topics, but still, some of you got like 3, 5, 7, something like that. So, come on. The derivatives. Well, fine. But be careful because yesterday I got inside Blackboard and at least half the group hadn't done it, so I need to be careful with that. 5 points. The partial grade. There will be another one. And don't forget about your projects, huh? The project is going to be next Tuesday. Well, Monday night.
For the project, do we need like a background research and all that stuff?
No.
Just so
No problem. We'll do a cover page with your yeah. And upload it to discussion board. Let me change that because I think it's white. Fine. Okay. Fine. Ready? Anyway, while you finish this, we're going to start with the second module of the semester, which is techniques of integration. I consider this to be a little more difficult than the previous topics, and to pay attention. Also because the schedule is one technique per page. So, but don't worry about that. The idea is that we're going to see the 5 techniques this week, and the next week we're going to practice with all of them at the same time. No, the quiz is going to be the next Friday, not this Friday, the next one. Okay, so you still have time to catch up, have trouble with these topics. Okay, fine. The first technique, a very fun technique, is called integration by substitution. You need to remember 2 things. The first thing is about the function composition. A topic that you saw in Math 3, remember?
Yes.
Yeah, and the second thing is the chain rule, which is basically the next part of the composition. Chain rule. Why? Because this technique, substitution, is basically the inverse of the chain rule. Okay? The inverse of the chain rule. So if you're good with chain rule, if you were good with chain rule, then you will find with this. If you're bad with chain rule, then, well, too bad. Okay? So, the idea of the technique is that there are some integrals, such as those two, that they cannot be solved directly with the basic rules. For example, the first one, when you have a square root, and you have this, you have that. Can you solve this with the basic rules, the one that we saw last week? No. Even if you rewrite that, you cannot multiply, because you have everything to a power. So there's no way to do it. Or this one, for example, imagine doing this to the 4th power. No. Too time consuming. Not possible. So the idea is that you need to observe. Do very observant, because if those integrals fall into this pattern, you need to apply the substitution method. But what I mean by this pattern here, observe. This integral has 2 functions. This function, these compositional functions, where you have an inner function inside of another one, and multiply by the derivative of that inner function. If you observe, this is basically the solution of the chain rule. So the idea is that if you have this, by integrating, we're going to go back to what it was, a composition of functions. So you need to observe. If you have an integral where you have a function instead of another one, and the derivative of that function is also there, you need to apply this. Example, check this one. You have 3x squared, square root of x to the cube plus 1. If you observe, you have x to the cube plus 1 inside the square root. This is my inner function. And mentally, the derivative of this is what? 3x squared, which is here. Okay? So, or this one, for example. Tangent of x plus 1 is inside the 4 power, but the derivative of this one is what? Secant square of x. Is it there? Yes, it is. Okay, so those two, for example, fall into this part here. That's the observation part. That's the first step to do. Observe if this can be done like that. For that, you need to find the derivatives mentally. Okay? So, by now you need to do that. Very good. Okay? Porque si no saben derivar así ya, así, pues van a tener problemas con esto. No siempre. No siempre. Ok. Ajá, mental. Porque si no lo hacen mental, no van a saber si de verdad lo hago con esta o con otra técnica. ¿Sí? Tienen que saber ya desde el principio, ver, está la función, paso derivada ahí, hago esto. O sea, de que, sí, o sea, por ejemplo, si tú no ves así ya, verla, no que tengas que escribir, pero si tú no ves que su derivada está ahí adentro para poder aplicar esta, pues no sabes ni cómo empezar. Este es el problema. Okay, now, once you have that, once you know that it's this way then to do, what's the next step? The next step is, you're going to do it directly. We're going to substitute. We're going to rename the function in a way. For example, we're going to change the g of x into another thing. We're going to substitute by a variable. We're going to call this variable u. Why u? Because it's the standard for this. You could call it a different way. You could call it pepe if you want. It doesn't matter. But u is the best variable to use. So the idea is that we're going to change the g of x by a u, such as this. G of x is going to be u. And then from this, we're going to differentiate with a differential. U differential is going to be du, and g of x differential is going to be g prime of x dx. And by doing this, now we can rewrite the entire integral into an integral in terms of u. The u here is my g of x here. My du here is my g prime of x dx. So at the end, we have a simpler integral to solve that can be done with the basic rules. Maybe it's a little confusing because this is the variables, but we're going to do examples, okay? So you have the simple integral, we solve that integral, and then we just go back to what it was in terms of x. Okay? We'll do examples. But do you get the idea here? It's just renaming the integral into something simpler. Okay, let's do an example. This one, integral 3x squared, square root of x to the cube plus 1 dx. Okay, we have a function inside the square root, and the derivative of that function is also there. So, do this. The next step is to u. Which one is going to be my u? The inner function, which is x to the cube plus 1. And then from here, we're going to differentiate. My differential of u is going to be du. My differential of x to the cube plus 1 is going to be 3x squared dx, which is here. Don't forget to put the dx. The dx is important, because dx is also part of what I have in the integral. And now, we're going to rewrite everything in terms of u du. So now you have square root of u times du. I just rewrote everything. I rewrote this into u. And I rewrote 3x squared dx together into. Okay? Now, do you understand that?
Yes.
Now, question. What do we do now? Solve it. How do I solve this integral? First, I need to rewrite the square root, right? So it's going to be square root of, u to the 1/2 du, and the integral, it can be done, it's going to be u to the 3 halves over 3 halves plus c. So it's going to be square root of u to the cube, so thirds plus c, right? I just rewrote the powers. And the last step is to change u to what it was, which is 2/3 square root of x to the cube plus 1 to the cube plus c.
What is the I?
I is just to say integral, it's just an answer, like R as an answer. No need to put it that, it's just extra.
Okay.
Yeah.
Do we need to solve the cube function?
No. No. Just rewrite. That's answer. And if you're not sure of your answer, you can always find the derivative. And the derivative of this one, the derivative of this one should be this one. Which general, of course.
The derivative of this one?
The derivative of the solution that you got is the integrand, the expression inside the integral. It should be. And that's it. Questions?
No.
Of course, this is an easy example, yeah, but the idea is the same. Okay? The idea will be always the same. Good. Can I continue? Second example. In this case, is that with substitution? Yeah, because you have the function here, the derivative is there. So, which one will be by u? Tangent of x plus 1. Why the plus 1? It doesn't really matter, because at the end it's an entire function and the plus 1 derivative, it becomes 0. It doesn't change anything. Du, the differential of this, secant square of x dx. Common mistake, some people forget to put the dx here, but it's important. Because if you don't put the dx, there's no way to cover everything, right? So, if you don't put the dx, well, it's not complete. You lose points.
Profe, ¿por qué en ese el u del du no se le pone la raíz en el caso de arriba o es la cuarta?
No, because that's the function that is outside, which at the end is going to be the new integral. That's why, for example, in this one, the square root is in the new integral. I need to integrate this. For example, in this one, my new integral is going to be what? To the 4 power times the u. U to the 4 times the u. U to the 4 times the u. Can I solve that? Yeah. So it's going to be u to the 5th power over 5 plus c. So my final answer is going to be tangent of x plus 1 to the 5th power over 5 plus c. That's it. Questions? Good. Okay. We're going to do some of the samples from the POT together. The ones that I think are a little more complicated.
We can also find particular
We could, if I give you an initial condition. Well, bring it. Yeah, every time, but doesn't matter. This is going to be due next Wednesday. Next Wednesday. So you have time to do it. Can I erase?
No.
No, you don't have time, no problem. The other one, yeah, the one on the. No se me olvida, pero no va a alcanzar a calificarlo. La actividad de los single fields no alcanza a calificar hoy. La que era para hoy, los pido después. No alcanza para hoy. Era para hoy, no alcanza a calificarla. Lo pido después. Okay. Let's do some examples from activity. Yeah? Okay. Let's start with number one. Number one seems easy, right? You have cosine times sine times dx. In this case, observe. Is this with substitution? With this technique? Is a function there? Whose derivative is also there? Yeah? Yeah, listen, this one seems very simple, and it's simple, yeah, but still with substitution. There is no way to solve this directly. There is no clause here to separate them, for example, and there's no rule directly for integral of this one. There isn't any. So we need to use substitution. Which one will be my u? Sine, yeah. Sine. What's the du? The differential of this one? Cosine of x times dx. So, rewrite integral. What's the integral? U times du. That's it. Why? Because my u, the sine, doesn't have another bigger function outside. It's just multiplying the cosine, so it's u times du. That's it. Integral of that? U squared over 2 plus c, so it's going to be sine square of x over 2 plus c. That's it. If you were to decide to use u as cosine instead of sine, it can also be done. We can try. Imagine that instead of using this, forget about this. Instead of using sine, I use cosine, right? du. What will be the differential of cosine minus sine times dx? Now the question is, observe. Do I have the cosine in my integral? Yes. Do I have minus sine in my integral? Not quite. I have the sine. We don't have the minus, right? But can I modify this? So it's the same as in here? By doing what? By multiplying. Yeah, by multiplying. So if I multiply everything times minus 1, then this is going to become minus du equal to sine of x dx, right? The only thing that changes is the minus the du, but it doesn't matter because you're multiplying. So my u integral is going to be integral of u, which is the cosine, times negative du. Is that an addition or subtraction? No, it's a product. It's the same as saying negative u du. Because it's a coefficient. Do you follow what I'm doing? The integral now is going to be minus u squared over 2 plus c minus cosine square of x over 2 plus c. Is that the same answer as this one? Not quite, but it's equivalent to each other. If I find the derivative of this one or that one, the answer is still the integrand, cosine times sine. You could try it if you want. You believe me? Okay. Questions? Conclusion for this is that in case that the differential is not exactly there, but is missing, for example, a coefficient or something, you can multiply by another coefficient to match with the one that you have in there. We'll do more examples there with this. Questions? Okay, let's skip 1 to 3. Yeah. I'll skip 2, so I'll do 3. Number 3. Do you have a function whose derivative is in there?
No. Yes. Number 2?
Yeah. Well, the logical answer would be yeah to the activity, no? So yeah, it's there. But which one is it? Which one would be my u? E no. 2 no. Just a square root. Just a square root. But which one? This one or that one? Or both?
La de
No.
No, el 2dx, ¿no?
This one or that one?
El de abajo.
arriba. De abajo.
De abajo.
Listen. Again. Derivative. Mentally. This one. Right? So, if I were to rewrite that one, my integral is going to be e to the u times the u. Why? Because e to the u, and then this is a 1 here. There's a coefficient here, a 1. All of this is du. Multiplying, not dividing. I'll rewrite for you. If I rewrite this one, can I put it like this? Is it the same thing? Same thing?
Yes.
Yeah, right? If I have this, or I have that, is it the same thing? Yeah? So, e to the u times the u. The du cannot be in the denominator. Cannot be in the denominator. If you put it in the denominator, it's wrong. Something is wrong.
El du.
Du jamás puede en el denominador. No puede integrar así. No puede integrar así. Entonces, si lo tienen en el denominador, o pusieron mal sus funciones, o ni siquiera es con esta que tienen que hacerlo. Es con otra técnica. Que lo veremos. Entonces, ¿sí ven qué pasó? Por eso les digo, desde que la ven, tienen que ver ya cuál es la función y su derivada. Y ver si está ahí o no. Así es, así es.
Profe,
Es divertido.
¿cómo hacer otro en el que también sea como eso, pues, que sea dividir y se multiplicar?
Yeah, we'll do more there. Okay, integral. Yeah, the same. E to the u plus c. So my integral is going to be e to the square of x plus c. And again, if you're not sure of your answer, you can always do the derivative. Since you are very good with derivatives.
Creo que sale peor, profe. Si la queremos checar si está bien y nos equivocamos, pues ya. No se puede.
So much. Fine. Questions? Good. Can I move it? Can I move the detail? Yes. Okay. Let's try the fourth one. Well, okay, number 4. Just asking one. Number 4. Number 4 is easy. Which one is U and DU? Which one is U?
Number 4?
Number 4, yeah, this one. R? No. Ln of R. Why? Why?
Because 1 over R is
Exactly. Ln of R derivative 1 over R dr. Okay, so are those two things in this integral? Yeah. So my integral is going to be square root of u times u. Same situation. It's 1 over r. If I were to rewrite that in the beginning, you could see that it's 1 over r times the square root of ln over r times r. No, of r, sorry. Of r. And here. So the same situation as the previous one. We write and solve. U to that. 3 house plus c, so 2/3 square root of u to the cube plus c. Solution is going to be 2/3 square root of ln to the cube. No. Pleasure. Like this. Do you agree? If you see, it's not that complicated, right? You need to practice. Practice. Well, don't worry. There will be an activity. Apart from this one, there will be an activity which, I think, will be 60 integrals. So without the things, practice. Don't worry. Okay. Can I continue? Yes. Okay. Let's do some others that are a little more, well, let's say, tricky. Number 8. We'll do 9, but first thing. Okay. Number 8 is, let's say, fun. Yeah, why fun? Because you need to do some extra steps. And remember things from math 4. Yeah. Okay. Observe number 8. Just by looking at it, just at first glance, is it possible to do this with the substitution method? How? Yeah, it's an activity, so of course we'll do that. Now, but observe. Do you have a function and its derivative in there? No. But there is a way to modify the integral so it becomes something like that. Okay? Huh? Okay, you have secant to the 4th power, right? There is no derivative for secant in there, or for the 4th power in there. There isn't. But you can change it into secant squared times secant squared, right? Well, I can do it, right? Is it possible? Yes, it's possible. One of the secant squared is going to stay the same, but the other one is going to be changed using what? Okay, the cosine, bueno, cosine squared, no. 1 plus tangent square of x dx. Okay? Remember this one? It's not an integral. Anything from math 4. Can I separate that integral? Yes, I can. And what's the multiplier? Integral of secant square of x plus integral of secant square of x tangent square of x. Yes. I just multiply. So, in fact, I have two integrals. One with secant square, one with secant square of x tangent square of x. Yeah? Can I solve this one? Yeah. The integral is what? Tangent. Direct? Direct. For this one, integral is tangent. Plus, for this one, what do I do? This. What is u? No. Tangent. No, square no. Just tangent. The u is secant square of x dx. Are those in this integral? Yeah. Integral of u to the square du. Tangent to the square du. Integral of this u to the cube over 3 plus c. Tangent to the cube of x over 3 plus c. That's the solution.
Profe, pero ¿por qué multiplicaste ahí arriba?
Because I can.
O sea,
No, yeah, that's answer. Because I can.
¿no podrías hacer ya usar el método?
From here? Yeah, it's also possible. You could say 1 plus u to the square du if you want to, and then work with the u's directly. Also possible. Also possible. Yeah, the good thing about this is that there are plenty of ways to do it. So it's up to you. Questions? Questions? No?
Porque si una tangente cuadrada de x es secante cuadrada de x,
Huh?
se quedó un tangente.
¿Cómo se queda tan?
Ajá. Tangente cuadrada de x se multiplica secante cuadrada de x. ¿Por qué eso también?
Pues lo multipliqué, este por 1 y este por este. Ya luego lo separé, integré este, se puede directamente, es integral. Y este es u de u.
Profe, a la hora que integras el deu, ya no le haces nada al deu, ¿verdad?
Ah, no, ya no. No lo construye. ¿Aquí? ¿Aquí? Si lo pongo ya con u de u, sí. Así directamente como está aquí, en un solo paso, no. ¿Hubiera podido usar u de u en este paso también? Sí, es alternativa. Me va a dar lo mismo, nada más trabajando con u de u. Digo, hay varias maneras. Dos, por ejemplo. Ok, questions? No? Ok, one more. Well, number 11 and 12, you need to simplify before. No, let's do number 9. Number 9, so, can I read this part? Yeah, please. Okay, number 9. Secant to the, no, sine to the cube of 2x over 3 dx. Again, same situation as the previous one. I cannot apply u du directly. I need to separate first. How do I separate this? Sine of 2x over 3 times sine Yeah? Then I do what? I change this one. Sine of 2x over 3 times 1 minus cosine squared 2x over 3 dx. Right? Identity. Now from here to here is this one. Okay, fine. Let's do what Brandon said. Instead of multiplying directly and separating, we're going to do it using u du from here to see what happens. In this case, what will my u? Yeah, not completely. No. 1 minus cosine square? No, because if I use 1 minus cosine square, the derivative for that will be chain rule, will be bigger, and it's not there. No, u is just cosine. ¿Ok? No se vayan con la finta de decir, pues todo el paréntesis va a ser mu. No. Si yo agarro 1 menos coseno cuadrada con mu, su derivada va a ser algo mucho más complejo que no está ahí. Por eso les digo, deriven mentalmente. Derivative, du. Again. Chain rule. In here. No siempre las derivadas son. ¿Mandé? Chain rule. Chain rule. This. Sometimes you have chain rule in this also. Careful. Do I have minus 2/3 in here as a coefficient? No. So I need to multiply by what? How do I get rid of this? To do what? If I multiply this by the reciprocal, then it cancels and then you have just the sign, which is what you have in this integral. Yeah? So my new integral is going to be the coefficient, which is minus 3/2. You can put it outside. Integral of 1 minus u squared du. So I didn't separate in here, in like the previous one, but I applied u du. Still fine, but be careful, huh? Now I need to solve it. It's going to be solution of this minus 3/2 u plus 3/2 u to the cube over 3 plus it. Coefficient integral. Yeah? I simplify, minus 3/2 of u plus u to the cube over 2 plus c. Final solution, minus 3/2 cosine of 2x over 3 plus 1/2 cosine to the cube 2x over 3 plus c.
Pero al momento de poner la U, pues ¿por qué se omite el 1?
Porque ve el orden de funciones. Si yo quiero ponerle la U, por ejemplo, al coseno solo, el 1 está por fuera. Si tú le quieres poner U junto con el 1 adentro, o sea, ponerle la U aquí, por ejemplo, 1, o sea, hay que ponerle 1 menos coseno cuadrado. Que el cuadrado va primero. El cuadrado va a afectar el coseno antes que el 1. No puedo ponerle 1 menos coseno. No. Sería 1 menos coseno al cuadrado. Si el cuadrado estuviera por fuera de todo el binomio, ahí sí. U sería 1 menos coseno y luego poner el cuadrado en la integral. Sí, ve la diferencia.
¿Por dónde sale el menos 3 medios?
From here. So this value is not here. It's not there. And they complete it. How do you complete that? By multiplying, by doing this times this, you cancel that, so you only have the sign, but you're doing the other side also. You're balancing the equation. So when you balance the equation, so I put this, I added this, well multiplied times this, so now it becomes a new coefficient.
Pero abajo es la respuesta de los menos 3 medios.
¿Es esto? ¿Cuál es la integral de uno?
uno?
¿Cuál es la integral de 1? No es x,
Ah, sí, eso.
es sub, porque la variable es sub. Es como la t. Si la variable es de t, la integral de 1 es t. Si es 1 de u, la integral es u. Y el 3 medios que están multiplicando, es coeficiente.
Pero es como si hubiera multiplicado al menos 3 medios por 1, ¿no?
Ajá.
Nada más la
Y luego lo integro. O sea, me ahorré el paso de multiplicarlo antes y lo saco como coeficiente, en vez de esperarme hasta el final. Ok. Questions? No? Good, good, good. Okay, before I give you the exam,